The following is an instructional video for installing and removing Superbolt tensioners. You will learn how to make your installation or removal go smoothly by being properly prepared, by having the right tools, and by getting familiar with how Superbolt tensioners function. You may want to refer to your written procedure as you will be relying on it once you are in the field. Also keep in mind that although this procedure applies to most applications, it should not be used for crosshead nuts, mill motor nuts, and piston end nuts. Now let's get started. Superbolt tensioners come in both a nut and bolt style. The procedure is the same for both styles. For simplicity, we will reference the nut style tensioner only. The three primary components of your tensioners are the tensioner body, the jack bolts, and the hardened washer. To install the tensioner, first thread it onto the main bolt or stud. When the jack bolts are tightened, they thrust against a hardened washer and push the tensioner away from the bolted surface. The large bolt force required is achieved with a small torque input. Tremendous clamping force is created on the joint. Although Superbolt tensioners are simple in concept, it is important that proper procedures are followed. A copy of the procedure should have come with your order. You can also find the procedure in our current catalog. The procedure has been simplified, so make sure you have the latest edition. The following preparation steps will help assure a quick and easy installation. Thoroughly clean and deburr the main thread of the bolt or stud. Any contamination or small nick may prevent the tensioner from spinning into position. Confirm that there is no interference from the equipment components, that stud-to-stud spacing is adequate, and that the thread pitch was measured correctly. If possible, spin the tensioners onto all of the studs in advance of the job to assure fit. For cases where the stud extension through the standard nut is excessive, a spacer can be used to position the Superbolt tensioners at the ends of the studs. This assures that the stud will not interfere with the socket when tightening the jack bolts. Of course, for through bolts, any additional thread can often be threaded through the nut opposite the tensioner. Determine the jack bolt torque from the installation sheet supplied or by calling Superbolt. The installation sheet shows a table comparing jack bolt torque, stud preload, and the torque equivalent for a standard nut. The tensioner is often stamped with a standard jack bolt torque, but use caution because your requirement may be different. If you normally tighten to a specified stud stretch, call Superbolt and we'll help you convert the stretch to jack bolt torque. The correct lubrication is essential to assure proper preload. Superbolt tensioners require either JLG or JLM, although some commercial lubricants can be substituted. It is especially important to use JLM for the Molle series tensioners. Look closely at the stamping on the nut body. Molle series tensioners are stamped with the words, "Only valid with Molle lubricant." The jack bolts are pre-lubricated from the factory, but the washer face will need to be lubricated on location. Small packets of lubricant are shipped with new orders, but cans of lubricant should be stocked for later use. Having the right tools for the job is critical. Often 2 or more people can work simultaneously, so make sure you have enough tooling for all of the workers. Torque wrenches have some overlap in the torque ranges they can achieve. Keep in mind that repeated torquing is required, so you may want to choose a longer wrench to give you better leverage. On the other hand, it's often easier to use a shorter torque wrench in tight working areas. Air impact wrenches can be very helpful when tightening a large quantity of jack bolts. While air impacts are not precision torquing tools, they are reasonably repeatable at a given air pressure. Air impacts are used to build up the tension in the stud and get the jack bolt torque near the final torque. Different brand impacts have different outputs at a given pressure, and some have variable settings built into the tool. Call Superbolt for a guide to air tool selection. To determine the output of an air impact, tighten one jack bolt on the tensioner until it stops. Now check the jack bolt with a torque wrench. The torque required to advance the jack bolt further is the approximate output of the impact at that setting. Another important step is to choose the right sockets. Use only high-quality 6-point sockets. 12-point sockets are not recommended as they are prone to rounding. Even 6-point sockets can wear out, so have several sockets on hand for big jobs. When choosing sockets, consider the depth of the socket hex. Some brands are particularly shallow and don't fully engage the hex head. Sockets with a deep engagement will last longer and prevent hex rounding. Keep in mind that some Superbolt jack bolt hexes come in odd sizes, such as 9/32 and 11/32, and also in metric sizes. Planning ahead will help you avoid a work stoppage to find sockets. Sockets, wrenches, and air impacts can all be purchased from Superbolt. Your final preparation step is to mark the stud tightening sequence to avoid confusion during tightening. For circular flanges, it is easier to follow the correct sequence if the flange is marked with duplicate numbers at 180 degrees apart. This way, both number 1 studs are tightened, then number 2, and so on. A reference sheet for marking flanges is available from Superbolt. If you are tightening a joint other than a circular flange, check with the OEM in case you need to tighten in a different sequence. Now that the proper preparation has been reviewed, we are ready to begin installation. First, make sure that all components are properly lubricated. Stir the lubricant to an even paste as the solid particles settle to the bottom of the can. Install and lubricate the washers. Next, apply lubricant to the main thread. You may use either your standard lubricant or the Superbolt lubricant. For reinstallation, verify that the jack bolts have been freshly lubricated. Make sure the jack bolt tips are flush with the bottom of the nut and spin the tensioner onto your stud until it seats against the washer. For larger sizes, a nut runner may save time and effort for spinning the tensioners on and off the studs. After seating the tensioners, you may want to back it off slightly as demonstrated here. Anywhere from a 1/16 to 1/8 inch gap usually works well. The additional gap between the washer and nut body allows for easier oil application and improved penetration, especially for inverted applications. You should skip this step, however, if you are stretching a long bolt or tie rod, and also when closing a large gap between flanges to avoid running out of jack bolt stroke. Now we will begin tightening the jack bolts. A torque wrench can be used from start to finish. However, for large tensioners, standard air impacts can be used for the initial tightening steps. For the first pass, tighten 4 jack bolts at 90 degrees apart with a partial torque. Tighten each of the jack bolts only once, then move on to the next stud. Do this step for all studs on the flange. If using a torque wrench, tighten the jack bolts to approximately 50% of the target torque. If using an air impact with multiple settings, use the lowest setting. An inline pressure regulator can also be used to reduce the output. Pulsing the trigger manually will also work to achieve a reduced output. Next, at 100% target torque, tighten the same 4 jack bolts. Do this for all studs on the flange. We will now tighten all the jack bolts at 100% target torque in a circular pattern. Do this for all studs, 1 round only, so that there is even compression on the joint. If you are bolting a gasketed joint, the load may shift from stud to stud during gasket compression. For example, if tensioner 1 is tightened, followed by tensioner 2 and 3, on the second round, tensioner 1 may be loose. Don't be concerned. Continue the procedure and don't spin down the tensioners that become loose. Repeat circular pattern until all jack bolts are stabilized. This usually requires additional passes. If using air impacts, switch to your calibrated torque wrench once the rotation is small. Stabilize the jack bolts with the hand torque wrench. Once all the tensioners have been tightened and stabilized, go back and spot check all of the studs to make sure that no settling has occurred. Now that we've covered installation in depth, let's take a look at the kind of results you can expect. As you can see, with the right tools and a little practice, bolt up with Superbolt tensioners can be quick and easy. Now that we have reviewed procedures for installation, we will discuss removal procedures. The key to fast and efficient removal of Superbolt tensioners is proper preparation and familiarity with the procedures. As with the installation, confirm prior to the job that the required tools and sockets are available. Either ratcheting wrenches or torque wrenches can be used for removal. Torque wrenches are usually easier to work with because they have a smaller head and are longer than most standard ratchets. However, if a torque wrench is used for removal, some manufacturers say that the tool will be less accurate for tightening. For service at elevated temperatures or in corrosive environments, apply oil to the jack bolts prior to removal. Apply the oil while the bolting is still hot. Petroleum-based oil can be applied up to 300 degrees Fahrenheit. For bolt temperatures of 300 to 600 degrees, synthetic oil must be used to avoid smoking. Allow time for the oil to penetrate, several hours if time permits. If the oil dries up, reapply as necessary. If the tensioners are inverted, apply oil in the gap between the nut body and the washer. The jack bolts have a small clearance with their mating female hole in the unthreaded region, facilitating the oil to reach the threads. If the tensioners are allowed to cool to ambient temperature prior to removal, first use a penetrating oil, followed by the hydraulic oil. The main point to keep in mind during disassembly is that the jack bolts must be removed gradually. Turn one jack bolt a quarter turn, then move to the adjacent jack bolt. Do this for all tensioners on all studs, turning each jack bolt a quarter turn. Continue in a circular pattern until loose. If loosening one stud affects the load on neighboring studs, be sure to bring them all down together, one round at a time. Finally, for high temperature applications, a more conservative 1/8 turn is recommended for the first round or two. Once all the jack bolts have been gradually loosened, spin the assembly off the stud. If you make the mistake of removing each jack bolt individually, the load on the remaining jack bolts will increase each time a jack bolt is removed. This overloading can result in getting stuck part of the way around and the remaining jack bolts may deform. If excessive force is used, further damage may result. If you experience any difficulty with jack bolt removal due to corrosion or oxidation, don't force it. Call Superbolt for a copy of our alternative removal procedure. Installation and removal of Superbolt tensioners is a simple process when procedures are followed. Taking shortcuts or skipping steps will likely add time to the job in the long run. If a question or problem arises at any point during installation or removal, please call us or visit our website for helpful tips.